It's day 14. We've been at this for 2 whole weeks now, and well, you can't stop now. We gotta keep going with these problems. And today's problem involves sand falling on top of us in a cave. So basically, we are parsing these groups of coordinates. Each coordinate denotes a set of contiguous lines. So these coordinates give us this set of lines. 3 points defines the two lines, and then this group of 4 coordinates defines these 3 lines. That's basically how our input works and how it creates this grid. And sand is pouring into this cavern, this grid, from this point at the coordinate 500, 0. Note on our y values increases, we go down, and the sand drops. It will drop straight down if it can. If it cannot drop straight down, it will go down to the left, then down to the right, and then it will just keep pouring in until we reach a point where the sand will now drop into the empty abyss below and past where all of our cliff space is. And in the first part of the problem, we are trying to calculate how many grains of sand are placed before sand starts falling into the abyss. Then in the second part, we discover it is not in fact an abyss, that there is another wall just below where our final bottom wall was. And now we just do the same process over again. We just drop sand in until the source of the sand itself gets blocked. And we're just going to count that number of grains. So, how do we solve this problem? Well, first of all, parsing it is not too bad because we're just doing line by line parsing, and each of these lines is pretty simple. We use sepby based on the arrows here, and then within each character pair, we just have 2 positive numbers and a comma separating them. That's pretty easy parsec code here. So, like I said, sepby this arrow string, get our numbers, 2 positive numbers, turn this as a tuple, and we separate all that line by line. Now, the tricky part is ultimately we want to take all these coordinates and turn it into a hash set that has all of the coordinates where it is blocked, where there are rocks and the sand cannot fall. And so there's this slightly tricky build initial map function. It's just nested loops, more or less. We have to loop through this nested set of coordinates because remember, each line returns a list of coordinates. And then for each of these, we have to go through that list and we have to continue considering the first 2 in the list at any given point. So our base cases are, if our list is empty, that's a base case. If there's only 1 element, that's a base case. But if we have 2 coordinates, then we have to make a line from those 2 coordinates. Our lines can either be horizontal or vertical. Otherwise, I guess we'll throw an error and return no coordinates. But really what's going on is we're using list comprehensions to just fill in all of the coordinates in between those 2 endpoints of the line. And we just do some looping. We insert it into our hash set of coordinates, recurse on the remainder of the list, but notice we keep the second coordinate in the list when we recurse. And that will give us the proper set of coordinates. Moving on, how do we solve this problem? Well, I basically did it twice, or copied a lot of my code from part 1 into part 2. There's just a subtle difference between how each of these works. In part 1, we have this drop sand function. So that we have a single grain of sand and we're tracking what happens to that. Does it fall into the abyss or does it land at a particular location? If it lands, we want to insert it into our hash set. We take our hash set of occupied coordinates and return a new hash set where we might insert that coordinate. I suppose I could have just returned the coordinate itself and did the insertion up here, but either way. There are just a bunch of cases with where the grain of sand is. If the sand in part 1 is beyond the maximum y value, if it's gone down below where our rock coordinates end, then we're at the end of this. So we can say false. We want to tell our calling function to stop dropping the grains of sand because we're done. They're all going to fall into the abyss after this. So this is our base case. Then we have 3 cases that are all going to recurse with drop sand. So this first case is, okay, we have an empty space right below us, x, y plus 1. In that case, the grain drops into that empty space, and we recurse and see if it drops any further than that. So drop sand with that same coordinate. Next 2 cases are basically the same, except this is x minus 1, so it's dropping down to the left. This is dropping down into the right. And then we have our last case, or I guess you could say second base case. And in this case, we know that all 3 of these spaces are occupied, so the grain cannot fall any further, and therefore we will insert this coordinate into our hash set of filled spaces, and we will return true, indicating that we have successfully placed this grain of sand. It does not fall into the abyss. So the function that calls that, what does it do? Well, we drop a grain of sand. It starts with its coordinate here, 500, 0. This is just the starting position and our initial hash set. And we get 2 outputs of this. We get the new set in case we have inserted the landing space in there, and we get whether or not it has landed. So if it has landed, we recurse. We call evolve state again. Sort of weird name, but it's a boilerplate name for this function. But everything is the same except that we are using a new set. Again, we may have inserted into this set. In fact, we certainly have inserted into this set in this case. And then we increment a count. Previous sands, this is just the number of grains of sand. We have to add 1 to that because now we have another grain of sand. Otherwise, we return our count. If once it starts falling off the edge and we return false, we return that count. This gives us our answer. The only tricky part is we have to go through all of the second values, all of the y values in our hash set, determine the maximum one of those, and pass that as a parameter. Okay, that's part 1 done. Part 2 is very, very similar. All that changes is the end conditions. So now, because we're always going to have that bottom layer that will catch everything, if y is greater than max y, we're always going to insert it. So we're going to insert xy here into our filled spaces, and we're going to return true because we can still keep recursing after this, or keep recursing from evolve state. Middle 3 cases are exactly the same. If we have that empty space below us, we're just going to keep dropping the sand there, and we'll just continue to drop the sand. Or I should say we are continuing to drop this particular grain of sand. And in the otherwise case, now we might return false in this otherwise case. So we're always going to insert it into our filled spaces. But if we have determined that the place where we are situating this new grain of sand, if that is equal to our starting location of 500, 0, then it is actually time to stop running our evolve state function. So we should return false. So if it is equal to 500, if we are placing a grain of sand at 500, we have blocked the grain of sand. We have blocked the source of the sand, and so we will return false with this condition. And so evolve state apostrophe, evolve state prime, if you want to call it that, does essentially the same stuff as our prior function, but there's one little tweak, and that's we have to return previous sands plus 1 in this case, because we're not, we do want to account for that grain that was placed right there at the source of the sand. Otherwise, we're going to be off by 1. But this function, process input hard, is, I think, identical to process input easy. I could have just refactored those. Either way. And we get our solution. And some tests. You can see they pass, and I'll just run them again for fun. I've commented out all my tests from previous days because they were starting to take too long. But that's okay. So we get our answers, and we're done with day 14. So we will be back tomorrow with day 15. Day 15, 16, that's when it starts to... it's not just a little bit tricky, it's actually, you really have to think and write some good code starting on those days. So it's about to get probably a little bit more difficult the next few days. So stay tuned. Subscribe to our YouTube channel if you're enjoying these videos, and subscribe to the Monday Morning Haskell mailing list. In the video description is where you will find that link, if you are enjoying all of our Haskell content, both the videos and the write-ups. So thank you for watching, and I'll see you tomorrow.